Hi folks, welcome back to 7.5, part 2. And so in part 1, we took a look at some linear equations, some of the most basic ones, and now we're going to ramp it up a little bit. And we're going to start right here with this example 4a. All right, so we're going to take all the trigonometry out of it and think back to maybe middle school when we first learned how to solve linear equations. All right, so let's say we have 2x minus 3 equals negative 5. How would we solve for x? And the first thing we would do, I hope, is add 3 to both sides. And then we would end up with 2x equals, let's see, negative 5 plus 3 is negative 2. Okay. Then to get x all by itself, we just divide both sides by 2, and we get x equals negative 1. Okay. So not too bad, and also a good refresher of our order of operations when we're solving equations. Now, I'm going to zoom out a little bit and look at this. I've got 2x minus 3 equals negative 5. And then down here, I have 2 cosine x minus 3 equals negative 5. And so this x right here and this cosine x, right? If we kind of blur our eyes a little bit, this x and the cosine x basically occupy the same space in the equation. 2 times something minus 3 equals negative 5. And so it turns out that we can use the way we solve this here, along with what we did in the previous video, to solve for b. All right, so let's take a look. I'm going to copy the equation over. 2 cosine x minus 3 equals negative 5. And I'm going to do the same first 2 steps. I'm going to add 3 to both sides, and then I'm going to divide by 2. So I get 2 cosine x equals negative 2. Cosine x equals negative 1. Now, this looks pretty much like the questions we had in part 1. Okay, and the question we want to ask ourselves is to find angles with x values of negative 1. That's what we're looking for, okay? All right, let's draw ourselves a mini unit circle and see if we can use that to help answer our question. Right? And let's think, where is the x value of an angle negative 1? And there's only one place. In fact, that is at pi. Okay, so in this case, x will equal pi. That is our only solution over the interval 0 to 2 pi. Now, let's take this, let's duplicate it, and let's try for the general solution, right? Now, there's only one here. So x will equal pi plus 2 pi k, where k is an integer. That's it. Okay, so even though 4b looked a little more tricky than the ones we saw in part 1, as soon as we compared it to something that we already knew how to do, kind of made our life a little easier. Okay, so let's go ahead and move on to number 5. All right. So number 5. Now, there could be a lot of ways for us to solve this, but one of the things I really want us to think about is if we want to get something, if we want to get something out of a square root, and the square root is all by itself on one side, the easiest thing to do is to square both sides, all right? So I'm going to go ahead and square this side and square this side, and I get x minus pi over 2 equals 3 squared is 9. Okay. Last step, to get x all by itself, I'm going to add pi over 2 to both sides. And as gross as that might look, pi over 2 is just a number, right? So really, I get x equals 9 plus pi over 2, okay? Now, if I wanted to think about combining these into a single fraction, that could be fine. I just want to make sure I have a common denominator. But other than that, we can leave it just like this, okay? All right, now let's take a look at 5b here. I don't have a square root this time, but instead I have this x minus pi over 2 squared. So how do I get rid of the square? Well, I do the inverse of that, which is take the square root, okay? And when I take the square root here, I'm going to get x minus pi over 2 equals 16. Nope, not 16. What do we get? We get 4, okay? And now when we take our square root, all right, one thing that I want to make sure we really, really don't forget to do is this. Square root of 16 is 4, but it's also negative 4. When we take these square roots, we actually have 2 possible answers, okay? All right, in both cases, I just need to add pi over 2. So x equals 4 plus pi over 2, and x equals negative 4 plus pi over 2. And these would be our solution, okay? So let's take a look at 5a and 5b again. We've got 2 cases where we're working with squares and square roots and combining regular numbers with pi, and that's okay, all right? Now, let's take a look at 5c. All right, now I see a tangent, right? Instead of a square or a square root, now I've got a tangent. I'm applying tangent to this x minus pi over 2. And so what I need to do here is I need to figure out how to get rid of the tangent, right? What is the inverse of tangent? Well, it's literally inverse tangent, right? So we get inverse tangent of x minus pi over 2 equals inverse tangent of 1. And then the nice thing is this inverse tangent and tangent, they undo each other, and we're left with x minus pi over 2 equals inverse tangent of 1. Now, what is this asking us for? This is asking us for the angle where y over x, when I divide them, I end up with 1, all right? So what's helpful here maybe is to, again, draw a picture, see if we can figure out where this angle is. All right. Now, where on our unit circle do we have a y and an x value that when we divide them, we get 1, right? That's really code for saying y and x better be the same number. And in fact, that happens twice. Once here at pi over 4, and once here at 5 pi over 4, okay? So we've got our pi over 4 and our 5 pi over 4. That doesn't mean we're done quite yet, though, okay? What that means is that x minus pi over 2 equals pi over 4, right? And I'm actually going to move this down here. And x minus pi over 2 equals 5 pi over 4, right? Because it's this whole clump is going to equal this one and this one. So now my last step, just like before, I got to add pi over 2 to both sides. And I'm going to get x equals pi over 4 plus pi over 2. And x equals 5 pi over 4 plus pi over 2. Now, I've been doing math for a while, and so I can tell you that at this point, even though in 5a and 5b, I didn't combine the fractions, that it's kind of expected for us to combine these fractions. They both have pi's, and they're both multiples on the denominator of 2, right? So it shouldn't be too bad to find a common denominator. So we really get x equals 2 pi over, pi over 4 plus 2 pi over 4, which really gives us 3 pi over 4 as one of the answers. And if we do something similar over here, we get x equals 5 pi over 4 plus 2 pi over 4 will give us 7 pi over 4. All right, so one solution, two solutions. All right, now, one thing that is, again, really important here is that we make sure that we take this whole chunk, x minus 2, pi over 2, and that's what we set equal to whatever angles that we find here, okay? Now, let's take a look at the general solutions here, all right? The general solutions for 5C. Well, I'm going to go ahead and grab my two solutions from down here. So I know that I have 3 pi over 4 and 7 pi over 4. Now, if I throw those on a unit circle, right, I end up with 3 pi over 4 and 7 pi over 4. All right. Now, I could write them as two separate statements, but I'm not going to, and I don't want you to either. And the reason for that is that these two are exactly halfway across the unit circle from each other. That means we can just say x equals 3 pi over 4. So we choose the smaller angle. And then we say, instead of going one full time around the unit circle, we just go around half, or pi k. Every pi, we end up back at the same spot, all right? Where k is an integer. So I want to make sure we do this. Don't do this. Right? So don't write them as two separate ones like I'm doing in the red. Don't do that. Right? It is far more writing. And a lot of times when we check our answers with textbooks or other resources, it's already condensed. So I want us to make sure that we know we can condense them, right? And we can really only condense them when they are halfway around the unit circle from each other. All right, folks, we're going to stop here for part 2. Come on back for part 3.